C. Lindelof videos, AP Calculus, approximation of the area under of a region. This is an area problem because we're asked to approximate the area between the curve of f of x is equal to x cubed minus x plus 1 and the x-axis. So just to provide some clarification, on the closed interval 0 to 2, and we're asked to have 4 subdivisions, or n is equal to 4. So all I'm going to do is this. I'm thinking about this. This is crucial that when I read this problem on the exam, that I get the fact that I'm being asked to use right endpoints. So this is what this looks like. I'm going to show you what I'm going to do here. First thing I'm going to do is this. I'm going to find the width of my basis by doing b minus a over n, right? This is not trapezoidal rule. This is different. So I'm just going to find this width. So I have 2 minus 0. So 2 minus 0, 4 subdivisions, is equal to 1/2. That means I will be increasing my basis by 1/2 each time I move over. The question is, where do I start? In the last one, we started on the left. This one, we're starting on the right. Let's take a look quickly at what this looks like. So in the last one that we did the left-hand side. The rectangles were based on the height at the left-hand side. In this one, they are based on the height at the right-hand side. So remember, we were supposed to start at 0. So f initial, the first x value is 0 in this case. But the height of this rectangle is not based on this. It's based on this one right here. So I moved over 1/2. That's my endpoint, and I drew my rectangle. Then what I did is I went over 1/2, and 1/2 plus 1/2 is 2/2, otherwise known as 1. I found the height there. I drew my rectangle. And you can see in this case, it's a gross over-exaggeration, where in the last one, it was a little bit closer, I think. Same thing, I'm at 2/2. I keep increasing. Remember, we did our change at x was equal to 1/2. Our b minus a was equal to 1. Our b minus a over n was equal to 1/2. So we go over from 2/2 plus 1/2 is 3/2. Go straight up to here, right? You see that the right-hand side of this rectangle creates the height of the whole rectangle, and it gives me this one, right? Same thing here. I go from 3/2 plus another half to 4/2. 4/2, remember, is 2, and we're interested in this function on the closed interval 0 to 2, so I don't go any further than this. But I am going to go straight up from here, and there's that height. The height of this whole rectangle over here is based on this right-hand height. And there we have it. So you can see there's a lot of, here there's a little bit of an underestimation, isn't there? So right here there's a little bit of an underestimation, right? But here, gross overestimation, gross overestimation, gross overestimation. Here, so let's see what happens as we set this up. Remember, on the exam, you're only going to see maybe 4 subintervals. So I'm going to get this. I'm going to say, okay, I have my approximation is about equal to 1/2. That's my constant width times my height. And where do my heights start? Well, the first one is f of 1/2, isn't it? And I showed that in the other part of the video. F of 2/2. If you go back, if you rewind a little bit, you can see this is exactly what we did. F of 3/2 plus f of 4/2. You don't have to write this down, but I want to show you how I'm getting this. And from here, you actually have to do this math. You have to say, okay, I have 1/2 times, well, f of 1/2 would be 1/2 cubed minus 1/2, right? Plus 1. That's just me fitting this into the equation. Taking my x value and plugging it in up here into this equation, right? Plus f of 2/2 would be 2/2 cubed minus 2/2 plus 1, right? Just keep moving. Plus, now I have f of 3/2, so I have 3/2 squared minus 3/2 plus 1. I'm going to, do I have room? You know what, I'm going to slide this whole thing over. Plus f of 4/2. I'm going to write it as 4/2 so you can see where I got it, but it's 2, right? So I have 4/2 cubed minus 4/2 plus 1, right? Whoa. I would summate all of this. Remember, this is really important. I would summate all this crap on the inside here, and then I would multiply by 1/2 and get the approximated area. And the approximated area in this case, I told you it was an overestimation, because when we did it using left-hand rule, we got 2.75. This time we got 5.75 as the area, so the area is approximately equal to that. All right? So I hope this is really helpful. The next one I'm going to do is I'm going to do a midpoint of the same thing, and then finally I'm going to do the approximation using the trapezoidal rule and see what they come out looking like. All right? So thanks for watching. Any questions or comments, let me know. Keep working. You can definitely get this.